How about with no explanation? I'll negotiate. No explanation, just an answer. Said approximately 12 to 13 days. 12.5. Okay. Yeah, so what you're trying to do is it's important to establish what does median mean. And a lot of people understand one of the definitions is that it's the middle point. But then the middle point doesn't really translate to exactly what we're trying to say. It kind of means it, but you have to think about it a little bit harder. Middle point also means that 50% of all the data lies to the left and 50% of the data lies to the right. So it is in the middle, but also what does that mean about the data? So what you're trying to do is you're trying to find the middle point on this skewed graph. Now, it's obvious an approximation. I would say it's somewhere between 13 and like 16, somewhere in this range. It's not at the exact high point here because there's a bunch of data that trails off over here. If this were perfectly symmetric, then yes, the height would be the correct point, like right here. But because it's skewed, you'd want to like move it somewhere closer to 15, so between 14 and 15, because that would approximate about the middle. Okay. So D and E. Does anyone want to take a crack at D for me?
I don't know if my answer is right, but I'll go.
I'm impressed.
So I said that this area indicates that the probability of an individual who died due to COVID-19 between 14 and 21 days is 17.32%.
Yeah. Yeah, that's exactly right. It's saying that if you were to take a randomly selected person from this group, there would be a 17.32% chance that they died somewhere between day 14 and day 21 after they got symptoms. And so what about E? You want to take a crack at E?
I can try E.
Awesome.
So I said the area indicates that 17.32% of people died at 14 to 21 days.
Right. Yes, so that's correct. And that's establishing that of the total population of everybody, we say that this percent of them died at that point, at that range. The distinction between those two statements, D and E, may sound really trivial. It may sound like the same sentence, and you're not able to identify what the heck I just said and why those are two different words. Think about more when you talk about a group of people, like how many of them are this way, and then versus, okay, I'm going to grab someone out of a crowd. Okay, how likely is that they fit that category? It's a distinct difference and it's minute, but it is there. And part of it is reading that slide. Remind everyone, page 100, slide number 10. Okay. Any questions on this before I move on? Yes, we're definitely turning this in. We are turning everything you work on today is being turned in. You will have an extra day to do it. Okay. So I am going to have you guys go back into groups. You're going to work on page 92 and page 95, number 1 and number 4. you're going to want to, whoops, excuse me. You're going to want to remember this. I'm going to put it in chat. You're going to remember this for when you're working on them, because number 4 will be after number 1. This in chat. I'm going to forego, well, am I really gonna do that? No, I'm not. I'm gonna just have you guys do it. Sorry. I'm a fickle creature. I am going to give you guys a Jamboard. I want you to think about more. Don't worry about getting them perfect on the Jamboard. I more want you to just collaborate and work together. And I just want to be able to see that you are. You will not be graded on your Jamboard work. I just want to see that you're working on it. What I more want you to do is focus on completing your work today. I want you to focus up on working together, being as efficient as possible, and getting the work done together. We have a lot to do, and I don't want you guys to panic about getting your Jamboard right. So I'm going to have you guys 92, 94, 92, 95. I put it in chat. I want you to guys go to this Jamboard link, and I'm going to put you guys back in groups. Let's talk about the grid. Is anyone brave to share the numbers they got for their grid? And we can go piece by piece. In fact, let me do this. What did group 3 get for 18 to 29-year-olds for both cells? Yeah. Very good. How did you get those numbers, if you remember? It's not part of the quiz. It's just curious. You're okay. You're okay. I was fishing for the explanation. You're great. It was not part of the. It was not a canned answer. It's okay. Let me explain. So you did great. So the paragraph that you're referencing is exactly correct. That's where you get this information from. In the first sentence of the paragraph, it says, according to a Pew Research poll, 62% of Americans 18 to 29 years of age say that abortion is quote unquote not that important. So what that's saying is not that important for the column is not that important is 62.62 times 300. 62% of the total 18 to 29-year-olds feel this way. 0.62 times 300 is 186. And then to get the other one, you simply take 300 minus 186, you get the complement, and you get 114. Very good. How about group 1? What did you guys get for the total? Important versus not important.
Wait, so like the total for the column or?
The total for the column.
The total for important would be 470, and for not important would be 530.
Very good. Very, very, very good. Can you share with me how you got those numbers?
For not important, since in the paragraph it has 53% of all adults hold this view, I took 53%, so 0.53, and multiplied it by 1,000 to get 530. And then I subtracted that from 1,000 to get the important for 470.
Perfect. Exactly correct. Only thing I would say is, for those of you who are struggling with the language, complement is one of the ways that it works, but it's because the sum total is always equal. So the individual is always equal to the total. Take the complement, but it's exactly right. The paragraph says all adults hold 53% of this view in reference to the not that important. And so from there, you take, so you have, this is the order of operations, by the way, of solving the problem. From there, you can add 176 and 124 for 42 and up and get the total as 300. And then let's do group 6. What did you guys get for 30 to 41-year-olds?
For 30 to 41-year-olds, we put 180 for important, 220 for not important, and then 400 for the total.
Very good. Do you want to walk me through a little bit how you got some of those numbers?
Yeah. So for it said 53% of all adults, and that's like the only one we were missing. So we did 1,000 times 0.53, and then got 530. And then since we already knew the other two, we subtracted 530 minus 124, and then that minus 186 and got 220. And since we knew the total was 400, we just subtracted 400 minus 220 to get the important 180.
Very good. Exactly right. Now, if you heard that sequence and thought, oh, I did it a different way, and it's like, of course, no problem. As long as you got those numbers, you did it perfect. There's a couple ways to solve that last little chunk of the puzzle. But overall, those are the numbers. Those are the numbers you're looking for. And that's the general order of operations that you'd want to solve this problem with, is you just try to take what the problem gives you, apply it as best you can, and then, fill in the blanks. Know that, all the totals will sum up to each other, and use all that stuff to your advantage. And you solve it one at a time. Could you hear what those numbers are again? You sure can. In fact, let me give you this instead. Instead of hearing it again, let me just show you. There you go. And you can have access to the answers too for a second. And we'll talk about this one. We'll talk about these, but very briefly. All right. 3, 2, 1. So yeah, you got it, Damien?
Yeah, thank you.
Of course, I don't mean to call you out. I just need to move forward. Okay. So A solved itself pretty easily. We already talked about how you get A. For B, I want to talk about B. I know I showed the answer just now. All your answers can be in percent form, no problem. I don't think I told this class. I had to make these answer keys myself. Normally I am given the answer key. So all of these are with very little direction or understanding of how we're going to do anything. So this is mostly for me to reference. Don't take my formatting as gospel. It is just me writing stuff on paper. So for B, how did anyone get B? I know I showed everyone the answer, so if you didn't get that number, don't feel bad. We'll talk about it.
I did 300 from the total 42 plus year olds plus 530, which is the total non-important, minus the 40 or minus 186. Oh, wait. Sorry. I did 300 was a total 18 to 29 year olds. But 300 plus 530 minus 186 over 1,000.
Very good. You sounds like you logically applied the and the or, right? The 1 plus 1 minus both. But very logically applied that formula. The probability of A plus probability of B minus probability of A and B is what you're looking for. Very good. The answer is 644 divided by 1,000 equals 0.644. And then because we talked about the grid itself, the rest of these problems happen fairly one after the other. B is one of the ones that really throws people for a loop a little bit. But I want to talk about E. Oh, whoops. Sorry, oops. Thank you to the person that I direct messages. Thank you for catching that. What a boomer. So I will ask more about E. I want to talk about E a little bit. Did anyone find E possible? Did anyone take a stab at E at all?
I don't think it's really closely associated with age.
Okay.
Just because like the numbers are somewhat similar and they vary a lot.
Okay. What numbers did you get? If you don't mind sharing.
For like the whole thing?
No. So you compared 3 different ranges, right?
C and D, right? Yeah.
So no one reads my directions. So so one of the extra directions for this.
Oh, you did put extra directions. Okay, forget my answer then.
No, not at all. It's okay. No one reads my stuff. It's a miracle why I even put it. I should just not. For E, what you want to do is compare each range for the different age ranges. It's important that you do. This is how you can determine this relationship. Did anyone do that? I promise that if you say yes, I won't make you answer. I'm just curious if anyone did it. Okay, you guys are totally fine. Okay, so I implore you to compare each age range. You solved already for 30 to 41 year olds. The question requested you to do so. It gave you the percent for 18 to 29 year olds. So the only one you have to calculate of your own volition is 42 and up. And so I won't give you the answer to this one because this is kind of up to you to decide and you have to kind of move on. But what you want to do is get those numbers, get those percents or those decimals, whatever floats your boat, and compare them. And then, Skylar said it, you compare the numbers to one another. You can also compare them to the total and see, are they different in the total? That's the way the question meant to be answered. It is a subjective question similar to before. A better argued question, a question that is well argued is better than the correct answer. I will likely correct it with what I think is the right answer, but I will not mark points off if it's well argued. But you're trying to discern, are the percentages different enough from one another per age range? So that's what the question is you're trying to do with the question. Okay, I have 9 minutes to teach you something. I swear I get slower at this every time I teach it. You'd think it would be the opposite. Okay, let me pull it up real quick. So I'm going to give you guys a link. I'm going to talk about it pretty much. This is what we're going to talk about for the rest of, I sent it to one person again. Is P not important? The person who said, is P not important given 42 plus equal to 0.706 divided by 1000? No. It is not. Okay, I sent you a LibreText thing, and we're going to do for what it's worth. This seems like this is way too much, and I agree it is too much. What you have left to do is all going to be like the same. It's going to be very, very similar every part. You're going to want to use page 104, and we're going to use the LibreText thing that I sent you guys. This thing. So, LibreText. This is an excellent tool. You don't have to use it. I recommend it. We live in the future now where you don't have to necessarily use a TI-83 calculator, 84, whatever. So, and this is much, much, much easier, I think. I think it's more intuitive. And so we're going to use this to solve number one. And I'm going to do it basically with you / for you. Oops, come here. So turn to page 104. Look at this. We're going to be doing all 6 of these. And with this calculator. So for the first one, you might think, okay, well, how do I input a lower bound? And I think what I heard is the professor used 0. That's not wrong in this problem, but I don't recommend it as a general practice. You're trying to use negative infinity as the lower bound always, because that's how it's defined. But first and foremost, you want to enter the mean and standard deviation for the problem, which it gives us as 115. And then the lower bound is an incredibly small number. It is the left. You want to go to the left as far as you possibly can. I am just going to do -1 followed by a bunch of zeros. Just whatever close arbitrarily number of close to infinities you can get. It's totally fine. And the high, I'm going to put as 115 because that's the number that they give me as the upper bound. And then I'm going to leave one thing blank because it needs one blank to work. Can't have 2. And hit calculate. And this will give you, that fast, the area under the curve, the probability of it being 115 or less. So similarly, you have to delete everything, not everything, but you have to delete things. It doesn't automatically clear it. So for the next one, it shows 90 and up, the probability that it's greater than 90. So the lower bound is 90. Upper bound, similar to lower bound, is as big as possible. So 1 followed by many zeros. Mean stays the same, standard deviation stays the same. And then you want to find the probability. P stands for probability. And hit calculate. And this is your number.
What do you want us to round to? Just the first 4?
Yes.
Okay.
For these probability things, 4 is preferred. And that's your probability. That's the probability that's greater than 90. And then for the last one, for the this one, delete, 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 delete. Keep standard mean and standard deviation the same. You want to put the lower bound as 75, upper bound of 115, because that's what it's saying. It's saying, what is the area between 75 all the way up to 115? What is the probability of that happening? Exactly. Now it's this number, but you have to be careful because you have to round. You want to make sure you notice that this is 4 decimal places, but this is a 5. Oops. And so you want to round up. So it's set 0.7936. That's that. So for this next one, find the indicated IQ scores and round to the nearest whole number. What do we think I would put in these boxes? Interesting. So every time I try to calculate the P, it always appears to be NaN. There must be something that you're not. I don't know. I don't know why it tells you that. Maybe you're mixing up your bounds. Are your bounds bigger? Is your lower bound bigger than your upper bound? No. I don't know. That's very strange. Try refreshing the page and making sure you have all your numbers right. Someone said put 0.8 as P. Very good. And then lower bound, what do you want to put? Justin, negative number as close to infinity as possible. Justin, you are very correct. I'm getting some good questions. Why do we put 0.8 as P? Good question. And then random numbers, another good question. So to everyone asking this question, Justin correctly put negative number as close to infinity. It would be negative number as close to negative infinity, but the sentiment is correct. It's not a random number. It is a number that is very, very, very far away. You're fine, Justin, you're great. It's a very, very, very negative number, really far away from the mean. You want to get as far away from the mean as possible because you're trying to sum up all the area under the curve. This is a calculus thing, and we don't teach calculus, so I have to kind of dance around it. But that's why you want to put the lower bound as really, really big. It doesn't have to be infinity. I think 0 even works. It's sufficiently far away from the mean. But as a general rule of practice, you want a number that's really, really, really far away from the mean to get a really accurate result. The reason we put P is 0.8 is because this is the area under the curve that they give you. So in the first question, you have 0.8 is shaded as yellow, and you want to find what the high value is. And so you're just saying I know the area is 0.8. I know the lower bound is negative, really, really, really negative number, negative 1 million. I want to know what the upper bound is, and it will do that. All this information, it'll calculate it for you, like so. 112.62, or rounding to the nearest whole number, 113. Similarly, I wanted to find the next one, which was P is equal to 0.65. The probability under the curve is 0.65. The high value is real big. And the low value is unknown. It's an X. It's not clear what it is. It doesn't say what it is. And so then you calculate. And you end up with 94. And the closest one is 94. You round down here. So it'd be a 94 for this part. And so last but not least, and we are out of time, just like Back to the Future, we have a last problem, and this is important. There's two numbers and only one value. So I would normally walk you guys through this really carefully, but I'm a minute in overtime and I can't afford to. Know that what this is saying is that this is the middle 60%. It is the very smack dab in the middle. So we know that because it's in the middle, that we have an equal amount on either side, because the area under the curve is 1. So 1 minus 0.6 is 0.4. So we know that the white spaces on either side, we know that the white spaces on either side of the yellow here, these two must add up to be 0.4. And so we know this is in the middle. These must be the same size. These must have the same area. So we can say they're 0.2 individually. Each one is 0.2. And so what we do is we say, okay, well, we know it's 0.2. We know that the lower bound for, let's say the X, this is for X1. We know that lower bound is negative, really big number, and the upper bound is unknown. And so we get 87. Similarly, if we want to find X2, there's a couple ways we could do this, but the way I recommend you try it is you take the lower bound as nothing, upper bound is a really big number, same area, and calculate. You get 113. That is all the time I didn't have, and then some. You are going to be turning these questions in. Oops, Daisy, come on. And you'll have till Sunday by midnight to do this. I apologize profusely for how I've kept you over 2 minutes. That's life today. I have 2 minutes of your life that I can't give you back, but hopefully it was worth it. If you don't have any questions, you are free to go. If you do, I have 7 minutes before class starts.
I had a quick question.
Yeah.
So after finding the two sides, do we just like add them and subtract them from a 1?
What do you find the two numbers, and you don't like, so if you want to find the lower and upper bound, those are the x1 and x2.
Okay.
You find
so
those
do
numbers.
we just keep it like that?
Right.
Okay.
What the subtracting from 1 has to do with finding the probability under the curve.
Okay, got it. Yeah, it makes those two things. Thank you so much. Have a good
Of
day.
course. You too. Have a great weekend.
Have a good weekend, Professor.
You too.